Hey there, today we're diving into the fascinating world of physics to explore Archimedes' principle and buoyancy. Let's get started. Archimedes' principle is named after the ancient Greek mathematician and inventor Archimedes. It states that any object completely or partially submerged in a fluid experiences an upward force equal to the weight of the fluid displaced by the object. Imagine you have a boat floating on water. Picture it gently bobbing up and down, surrounded by the serene expanse of a lake or the vastness of the ocean. As the boat moves, it pushes water out of the way, creating a space for itself to glide through. This movement is essential for the boat's journey. The water that gets pushed aside is called displaced water. You can see it splashing and forming waves around the boat. The weight of this displaced water is what creates the upward force known as buoyancy. This buoyant force is what keeps the boat afloat, counteracting the force of gravity. Let's see this in action with a simple experiment. Experiments are a great way to understand scientific principles in a hands-on manner. They allow us to observe phenomena and draw conclusions based on our observations. Here we have a bowl of water and two objects, a rubber duck and a metal coin. These objects will help us understand the concept of buoyancy and density. Notice how they are different in size, shape, and material. When we place the rubber duck in the water, it floats. This is because the rubber duck is made of a material that is less dense than water, allowing it to stay on the surface. Why? Because the weight of the water it displaces is equal to the weight of the duck, creating enough buoyant force to keep it afloat. This principle is known as Archimedes' principle, which states that an object submerged in a fluid experiences an upward force equal to the weight of the fluid displaced by the object. This is why the rubber duck floats effortlessly on the water's surface. Now let's try the metal coin. Notice how it looks shiny and solid. When we drop it in the water, it sinks quickly to the bottom. This happens almost immediately. That's because the weight of the water it displaces is less than the weight of the coin. The density of the metal is much higher than that of water. The buoyant force isn't strong enough to keep it afloat. Therefore, the coin settles at the bottom, demonstrating the principle of buoyancy and density. Archimedes' principle and buoyancy have many real-world applications. Ships and submarines rely on these principles to float and navigate. Even hot air balloons use buoyancy, but with air instead of water. Fun fact: Archimedes reportedly discovered this principle while taking a bath. He noticed that the water level rose as he got in, leading to his famous exclamation, "Eureka!" which means "I have found it." And that's a quick dive into Archimedes' principle and buoyancy. Thanks for watching, and remember to stay curious and keep exploring the wonders of science. See you next time.